Okay, last class we learned about standard form and factored form. Factored form is easier to solve. So for the rest of the chapter, we're going to practice factoring so that we can make equations easier to solve. Okay, before we get to that, I'm going to do these first two problems at the top. I'm going to multiply these out, which is what we did at the beginning of the chapter. Remember, if I do 3 times x minus 5, I'm distributing or I'm multiplying. So this will be 3x minus 3 times 5 is 15. For the next one, it's similar. If I distribute to all three terms, 2 times 5 is 10. X to the fifth, because I add the exponents, minus 2 times 3, 6. X to the fourth, because I add the exponents, 2 times 4, 8. X to the third, and I keep the exponent there. Okay, so when I go in this direction, this is multiplying. Or it could be called distributing. But this is what we did during the first half of the chapter. Okay, now we're going to start with the bottom, the answer as our problem, and we're going to go back and put it in parentheses. This is called factoring. Okay, so if I start with the answer and I go back to the parentheses, that's called factoring. And that's where we're going to spend a lot of this chapter on, starting with what we used to consider the answer, but now we'll consider it the problem, and then we go back and try to get it in the parentheses. Okay, so for these examples, we're going to factor out the greatest common factor. Okay, I'm going to go ahead and look at example 1. This is a trinomial. It has 1, 2, 3 terms. Okay, the first thing I want to check is if there is a number that will divide into each of the 3 terms. So I see a 5, a 15, and a 10. A number that will divide out of 5, 15, and 10 is 5. And I actually want to take the greatest common factor. Then I want to check if they have any variables in common. This has x to the third. This has x. This does not have a variable. It doesn't have an x, which means I can't take out a variable. Okay, so I'm going to take out a 5. Okay, now I'm going to do the opposite of distributing. I'm going to think about what did I multiply this by so that I got this as the answer. So 5 times something to get 5x to the third. That would have to be 5 times x to the third would give me 5x to the third. I'm going to bring down the minus sign. 5 times something would give me 15x. Well, 5 times 3 gives me 15. 5 times 3x gives me 15x. I'll bring down the plus sign. And then one more term. 5 times something equal to 10. Well, that's 5 times 2. Okay, now I factored it. I took out the greatest common factor, and it's in factored form, and that's my answer. Okay, let's go ahead and look at example 2. Is 12x to the second, or 12x squared, plus 14x minus 10. Okay, again, the first thing I'm going to do is check each of the coefficients and see if there's a factor or a number that will divide into 12, 14, and 10. Well, they are all divisible by 2. Is there anything higher than 2? 10 divided by 2. Let's see, 3. No, 14 doesn't divide by 3. 5. No, 12 doesn't divide by 5. So 2 is the best I can do. So let me take out a 2. Let me check and see if they have any variables in common. This has x squared. This has x. This has nothing. So I'm going to ignore. I'm not going to worry about the x's. Okay. Now I'm going to factor out the 2. And I'm going to think 2 times what will give me 12x to the second. Well, 2 times 6 gives me 12. 2 times 6x to the second gives me 12x to the second. Okay, now 2 times something to give me 14x. 2 times 7 gives me 14. Because it has an x, I'll make it 2 times 7x. And then 2 times something to give me 10. 2 times 5 gives me 10. Okay, so this is in factored form. I took out the greatest common factor. Okay, for the next 2 examples, I'm going to add a variable. Okay, so let me check the coefficients first. I have 2, 11, and 8. Is there a number that divides out of 2, 11, and 8? 2, no, 11 doesn't divide by 2. So there's no number that I can divide out. Okay, let me see if there's a variable in common. This has x to the third. This has x to the second. This has an x. So all of them have at least an x. So I'm going to factor out an x. Now I'm going to think x times something to give me 2x to the third. Well, I need a 2 here. Okay, if this is an x times something to give me x to the third, I need x times x to the second. And because 1 plus 2 will give me 3. Minus x times something to give me 11x to the second. I need an 11. X times something to give me x to the second. I need x times another x. Plus x times something to give me 8x. I need an 8 there. I already have the x. Okay, so that's the best I can do for a factored form, or greatest common factor on this one. And let me look at example 4. Again, let me check x squared and 5x. The x squared doesn't even have a coefficient, so I'm not going to look at the numbers. I'm only going to check the variables. Okay, let's see. This is x to the second, and this is 5x. So they each have at least an x. So I'm going to factor out the x. X times something to give me x to the second. X times, I need another x to make x to the second. X times something to give me 5x. Well, I already have the x. I just need the 5. So x times 5 is 5x. Yes, that's factoring out the greatest common factor. Okay, for the next couple examples, I'm going to make sure there's a number and a variable that we'll factor out because that's also a possibility. Okay, first let me check the numbers. Between 12 and 4, I want to take out the greatest common factor. What divides into 12 and 4? They both divide by 2, but is that the greatest number that will divide out? They both divide by 4, so that's the greatest number I can factor out. Okay, next I'm going to check the coefficients, or not the variables. This is x to the third. This is x. They both at least have an x, so I can also take out an x. Okay, so if I take out 4x, 4 times something to get 12, this will have to be 3. 4 times 3 is 12x, but I want it to be x to the third, so I need x to the 2, so I can get 2 more x's. Bring down the plus sign. 4 times 1 will give me 4. 4x times 1 is 4x, and I already have the x on there, so I'm done, and I took out the greatest common factor. Okay, example 6, 9x to the fifth plus 6x to the fourth plus 3x to the second. Again, let me check for numbers first. I have a 9, a 6, and a 3. What divides into 9, 6, and 3? They're all divisible by 3, so let me take out a 3. Now let me check the variables. I have x to the fifth, x to the fourth, and x to the second. I could definitely take out an x, but I can actually take out x to the second because they all at least have x to the second. This has x to the fifth, which is more. This is x to the fourth, which is more, and this has at least x to the second. I want to take out the most possible or the greatest common factor. Okay, to get 9, 3 times 3, x to the, I need 3 more x's to make x to the fifth. 3 times 2 is 6. X to the 2, because I need 2 more x's to make 6x to the fourth. 3 times 1 is 3, and then for x at the second, I don't need any more x's. So that's good the way it is. Okay, for the next two, I'm going to add a negative. Okay, and then for each of these ones, this is called the leading coefficient. It means it's the first coefficient. The leading coefficient has a negative on it. If there's a negative on your leading coefficient, you normally factor out a negative. It's going to make some of the things we will learn later easier. But first, let me check the numbers. So negative 10, positive 15, negative 80. What can I divide out of 10, 15, and 80? 5, 5. But because the first term is a negative, I'm going to make it a negative 5. Oh, let me check the x's. X to the third, x to the second, and x. Since they all have at least x, and the lowest degree is an x, I'll take out an x. Okay, now I'm going to be really careful. Negative 5 times 2 is negative 10. X to the, I need 2 more to make x to the third. Now to get positive 15, that's going to be negative 5 times negative 3 to get positive 15. And then I need x times x to get x to the second. Okay, to get negative 80, I already have a negative on the 5, so I don't need a negative here. 5 times 16 is 80. You could use a calculator and do 80 divided by 5. Let's see, it already has an x, and so I'm done there. Okay, for example, 8 negative x to the third plus 5x to the second minus 7x. Now let me check the numbers. Well, there's no coefficient here other than the negative sign. So I don't really need to worry about the numbers, but I do need to take out a negative. I could take out a -1, or I could just take out the negative. Okay, now are there any variables in common? X to the third, x to the second, and x. Since they all have at least an x, I'm going to take out -x. And remember, if the leading coefficient or the first term is a negative, I take out a negative. Okay, -x times x to the second will give me -x to the third. To get a positive 5, and I have a negative, I need another -5. To get x to the second, I need another x. Okay, and then if I look at the -7x, I already have a minus, so I don't need a minus here. But I do need a 7. Minus x times 7 will give me -7x. That's the best I can do. Okay, you don't need to copy out down the last two, but I'm still going to show them to you because it's fun to factor. If you want to try them, you could definitely try them. For example, 9, let me check. Between -8, 10, and 14, I can take out a 2. Because the leading coefficient is negative, I'm going to take out -2. If I check the variables x squared, x, y, and x, they all have an x in it. So I'm going to take out an x. Okay, -2x times something to get -8. It already has a negative. 2 times 4 is 8. X times, I need another x. Okay, -2 to +10. I need a -5. It already has an x, but it needs a y. -2 to -14 already has a negative, but it does need a 7, and then it already has an x. And then that weird thing is my answer. Okay, and the last one, again, you don't have to copy examples 9 or 10, but they're fun, so let's look at them. Okay, let me check the numbers first. 12, 16, and 8. I could take out 2. I could take out 4. Can I take out 8? I can't take out 8. So 4 is the highest I can take out. Okay, now let me check really carefully on the variables. This has x to the third. This has x. This is x to the second. So they all have at least an x, so I'm going to take out an x. But let me check the y's. This has y to the second, y to the fourth, y to the second. They all have at least y to the second, so I'm going to take out y to the second. And that's because I'm taking out the greatest common factor, or the most I can, without going over. Okay, now I'm going to carefully figure this out. Okay, to get 12, 4 times 3. For the x's, I need 2 more to get x to the third. For the y's, I'm good. Okay, to get 16, 4 times 4. The x's already match. For the y's, I need 2 more. To get 8, 4 times 2. The x's, I need 1 more. For the y's, I'm already good, and I match.